here. Anyway, feel free anytime to announce if you disagree, and we can pause or stop the video for the particular talk. Yes, so that was one thing.
Chat.
Yes, and then the organization think about how to place the questions for the followers online. So we would ask you to actually define and write your question into the chat box so everybody can see it. And it will be much easier for us that we will always start with the questions which are on site, and then we will focus on the questions from the hybrid, from the online auditory. That was the second important point. And was there, let me get, yeah, here is it. Yeah, so the questions written. Yeah, so we will have in the first section always time for 10 minutes talk, and 5 minutes are allocated to the questions, and also some time is allocated between the talks. So we might actually start always a little bit also in advance. So please have this in mind that when it's online and both on-site conference, that the beginning time of the talks can little bit change. Great. So I guess now it would be time, and again, great pleasure to introduce here Dr. Alexander Baklano from the World Meteorological Organization, and he will give us also welcome talk and very interesting talk on the World Meteorological Organization Sand and Dust Storm Warning Advisor and Assessment System, so-called SDS-WAS, and its northern dimension. So, dear Alexander, please be welcome, and the online space and also our video here.
Thank you, Pavla. And now I'll share the screen and present. Okay, I hope you can see the screen. And first of all, I would be happy to welcome this important meeting, and it is really important also for us, for WMO, this activity, especially nowadays, and I'll say a bit more about what we call northern dimension of WMO Sun and Dust Storm Warning Advisory and Assessment System. Actually, this activity was initiated about 15 years ago, and Slobodan Nikovic was one of the initiator and kind of father of this system, and it is now approved as one of key activities of WMO, and organized around regional nodes and centers, integrated operational and research and user communities. And the main mission is to establish and coordinate a global network of sun and dust storm research and forecasting centers and activities, and enhance ability of all countries interested to deliver with good quality and in time forecast, observation, and other information and knowledge about sun and dust storms, and also impact on different areas. And as I mentioned, we have regional nodes, and for the moment we have a global steering committee for coordination of work, and also 3 regional nodes for NAMI node, what we call North Africa, Middle East, and Europe node, and with center in Barcelona, and many of colleagues from there are participating in this meeting. And from other side also we have Asian node and center in Beijing, and also Pan American node hosted by Barbados, and also with active United States and other countries. So as you can see, previously it was no focus on the Arctic and northern latitude dust, but interest is increasing step by step, and in our next science implementation plan for next 5 years, Northern Dimension is included as one of important area of at least research activities. And 4 priority areas what we consider for the next 5 years, which are considered now in the new implementation plan. And first of all, address limitation of understanding of physical and chemical processes of aerosol interaction with atmosphere and climate, and also with transport and chemistry. And of course, advanced methods for forecasting and also for retrieving dust mineralogy and size distribution, and also longer term forecast up to seasonal and climate projections and reanalysis. And of course, observations is one of the key area, especially for using new type of observations and methods. And of course, application is key area where we have to reach our end users and answer on requests from the society. And our 2 operational centers now providing forecast for 72 hours, and actually it's now some also forecast up to 1 week. And also analysis of trends. On the below, you can see average concentration of dust for 2020. And of course, for now it's also preparing such trends for 2021. And also from the right side, you can see a difference with climate averaged situation with increasing and decreasing dust. So you can see trends are different from area to area. And of course, as I mentioned, for end users, it's very important for us to provide data as impact-based forecast and assessment. And we work in this area with United Nations Sun and Dust Storm Coalition, which was organized a couple of years ago. And here also from right side, you can see one of last research project of our Japanese partners who are analyzing projections of climate change, different scenarios you can see up to 2090. And you can see for most of cases, for most of scenarios, we see increasing of dust emission from Asian sources, first of all, for Mongolia and for North China. And as I mentioned, middle and high latitude dust and aerosol sources affecting Arctic climate and environment are important. And especially here, we see what global amount of dust emissions is increasing up to 50% over the last century. So it's more and more important. And also Arctic regions are warming much faster than other regions of the world. So we have to care about our Arctic forcing, first of all, especially because last IPCC Working Group 1 report stressed the importance of dust, especially for the Arctic. And it's one of the reasons why we support very much your efforts, and especially teams with Pavla and also OT, now leading with analysis of new sources of dust in the Arctic and middle latitude, which are affecting Arctic environment and climate. And also great work was done by UN CCD, and Anna Vukovic prepared a great atlas of dust sources. And here you can see just extraction of this atlas for the Arctic, and now more and more activities linked with such sources. And team of Paula and Slobodan Nikovic, who are working now and already started forecasting for this region with dust sources. What I would like also suggest stressing, of course, we are supporting this activity and happy to collaborate, but it is also possible to think maybe about node for northern latitude dust as one of the regional focus of SDS-WAS activity. Of course, in this case, additionally to research, would be good to involve one of the or maybe several national hydrometeorological services for increasing also operational part of these activities. And if it will be such initiative, we would be happy to consider. But anyhow, we are glad to collaborate and further work, and we keep very close contacts with your network and with workshops that you organize, and especially thanks to Paula and Iceland for initiating all this work. And finally, just would like to mention about outreach activities and links to activities of our regional centers and some publications, including Airborne Dust Bulletin, where also northern latitude dust sources are presented, and your activity also we try to publish and increase attention to that. Thank you very much, and my pleasure to welcome this meeting, and good luck for continuation of your important work. If any questions, welcome.
Thank you, Alexander. We were already clapping here. So thank you very much for this interesting talk. I will go back to Teams here and check if we have any questions. So there are no questions, so I will ask here on.
Paula, sorry, can I have a few sentences related to what Alexander was presenting? So I would like really to thank also to Alexander for great support of several of our groups related to high latitude dust, and I like also very much his proposal to maybe think about another new node of the SDS was related to high latitude dust. I think there is already some potential for that. We can think about how to formally proceed with this initiative and end up with good results. And also thanks, Alexander, for really great support in general for SDS-WAS, because Alexander was fighting a lot to protect the objectives of SDS-WAS. It was not always easy over the last several years. And thanks to him, I think SDS-WAS now gets a very important international aspect of collaboration with UN organizations and some others. Thanks, Alex.
Thank you, Slobodan, for nice words. But of course, it is a success of the team working with SDS-WAS and all of you who are doing this activity. We are happy just to support it. Thank you.
Yes, I also have to just exactly agree what Ničko said, Slobodan Nickovic, and it's a great support from the side of Alexander and his background and everything. So I will ask if there is.
I could ask one question.
So there is one question here on site. Otis coming to ask.
Yes, thank you, Alex, for the most interesting presentation, and Ničko also for commenting. I would actually like to ask Alex about what do you think about the importance of black carbon versus dust? As you showed in one of your slides, there was this AMAP report on black carbon as well. So previously, most effort was put in high latitudes and Arctic regions for the black carbon, but now I think the dust has gained more attention thanks to all of your activities. So how do you see the situation from the environment and climate point of view?
Well, if we thank you for the question and this focus on black carbon issues and climate forces. Of course, black carbon, it was first gas what should be considered for Arctic forcing due to deposition to snow and albedo impact. But it became clear what additionally to black carbon, of course, many other sources should be also considered. But for black carbon, of course, we have to care not only as climate forces, but also important for health impact. And this win-win strategy for reduction of black carbon emissions, especially from, and not only actually from Arctic sources, but also in many cases mid-latitude, because specific of circulations to the Arctic leads to integration of sources within the Arctic environment. So quite large area should be considered for analysis of impact of aerosols and in particular black carbon. But returning to dust sources, it is also important, and in many cases previously researchers paid not enough attention to other type of aerosols and dust. Of course, for sulfur aerosols, there were many studies and also kind of speculations because in comparison with black carbon, sulfur aerosols could be reflecting and give opposite effects for climate forcing and for health. So it was, but now actually sulfur particles are not so big source, and also for health impact, it's dramatically decreased impact. But for dust sources, other type of dust, and first of all, dusting surfaces, what are considered in our SDS-WAS program and also in this workshop. Of course, I think we need to put more efforts, and not only for forecasting, but also for longer term analysis and trends for climate forcing. Because it is also important, and the last IPCC report especially stressed that.
Okay, thank you very much, Alex.
Thank you. So yeah, we look forward to the future, and hopefully it's gonna lead towards great success in high latitude dust research.
And actually, just thanks to your initiative for this collection of information about sources of dust. And please consider seriously idea of this knot or some kind of regional focus for Arctic and northern latitude dust within the SDS-WAS. But as I mentioned, it is important to involve meteorological services in this activity. Maybe FMI will be also, additionally to Iceland Met Office, will join efforts in this direction. So please, your initiatives are welcome. Thank you very much.
Yeah, I mean, OTE already has a small team on high latitude dust modeling, isn't it?
Yeah, well, of course, we have the SILAM model group there, so collaborating with DREAM and with SDS was, of course, part of the models there. So yes.
But so far, the pioneer, of course, is Nichko and his team in with DREAM model.
Ilam is contributing actually to all our regional nodes. He's their global model. So FMI is already actively involved.
Yeah, as soon as the let's say north node would be implemented, whole hemisphere would be covered with dust in the model. All right. So, dear Alexander, thank you very much, and we will proceed now to the next speaker, and I will probably leave on the introduction.
Yes, so it's a great pleasure to have Jan Kavan from Czech and from Poland institutes as our invited speaker. And he has, like Pavla introduced in the very beginning, experience from Svalbard, from Iceland, from Antarctica, and also about permafrost and dust, which is one of the issues that is interesting. So how is frost and permafrost connected to dust events and dust sources and possibility of creating new dust sources? So Jan is a doctor originally from University of Brno in Czech, and now he is associated with Poland University of Wrocław. So and he has studied quite a lot of different subjects and been participated in studies related to penguins, from penguins to the atoms, and his work emphasizes the cross-disciplinary research in polar science. So it's a pleasure to have you here. Welcome.
So thanks, Uti. I will sit and
Yeah,
show the
okay.
things
So
on
you
screen.
probably just in the case something is not working. There's we still have even more
Yes.
time.
So I'll try it again.
You just click on the screen and share. Yeah, now it should work. And then
So you can see it.
yes. Right.
So first of all, thanks very much to Pavla and Oti for inviting me, and good afternoon to everybody here and there. And as Oti already said, my talk will be about Antarctica. It's probably the only talk on the workshop, and I will not go too much to the details, but I would like to show you like the impacts of the Aeolian processes on the local landscape, because we are actually localized on the tip of the Antarctic Peninsula. Here you have the satellite map on the right with the special area of interest. This is the northern part of the James Ross Island, which is called Ulu Peninsula. It's about 300 square kilometers. It doesn't sound like a big area, but in terms of Antarctica, it's one of the 10 largest deglaciated parts. So quite important dust source as well. And just few sentences for the background, or what is the motivation of studying the Aeolian processes and wind-driven processes. As you already know that Antarctica, and especially the Antarctic Peninsula, is one of the most rapidly warming regions of Antarctica, despite a short cooling period in like after 2000. And in the last years, there are many studies that focused on these like very dynamic climate processes. And it has been shown that there are a prolonged period of above zero temperatures, which are like a good conditions for aeolian transport or uplift of the mineral particles. Also, the higher absolute summer temperatures were recorded in the last years. I think the record temperature from this area is from 2020. It reached almost 20 Celsius during the summer in the Antarctic Peninsula. And in case of precipitation, the spatial pattern is very variable, as the western part of Antarctic Peninsula is getting wetter and wetter. On the other hand, the eastern part, where our station and the study site is located, it stays on the same level, or it's even drying. And these changes are also accompanied by massive retreat of glaciers on most of the part of the Antarctic Peninsula region. And also the ice-free areas are like getting larger. It has been calculated that in the few next decades, the deglaciated areas can even double in the area of like maritime Antarctica and around the Antarctic Peninsula region. This all have quite serious implications for the local ecosystems and for functioning of the landscape, because of course, the higher temperatures are leading to increased meltwater runoff from the glaciers until the point where the storage of the water in the glaciers is depleted, and then there is an important drying of the whole landscape. And this drying of the landscape is also associated with the shift from like fluvial-driven processes to more Aeolian-driven processes in the dry landscape. And this also very much affects the permafrost, especially the active layer on the top of the permafrost. The thickness of the permafrost active layer is increasing, and so does and on contrary, the water content in the active layer is decreasing. The surface layer of the permafrost is getting drier and drier, which are the good conditions for enhancing the Aeolian processes. Actually, there are quite numerous studies around Antarctica, which usually deals with aerosol observations. As these observations are based, I put a small map with some red dots, where there are like permanent observations of aerosol concentrations and chemical composition and stuff like this. But there are relatively scarce records of the Aeolian processes in terms of landscape shaping processes. The exception is the McMurdo dry valleys, as from the name itself, dry valleys. It's one of the most driest parts of Antarctica, and also the biggest or the largest area without the glaciers. So some important like Aeolian landscape is described from this place. However, on our place in James Ross Island, as you can see on the pictures, on the photos, the landscape is quite dry and it's not covered by any vegetation or anything. So it's a dry landscape with the bare soils, mostly consisted of sediments, which are very fine and easily eroded and transported by wind. So our motivation or the aim of our work is to describe or explain the functioning of the landscape and how the local ecosystems are affected by the Aeolian activity. So I pick up like 4 or 5 papers that we already published, and I will try to describe the most important things that we found in James Ross Island regarding the Aeolian activities and some future insights. So actually, the first paper where we hit the topic of the Aeolian processes is the paper from 2017, which deals mainly with the fluvial transport. But what we found is that when inspecting for the source area for the material that is transported in the rivers, so we found that it's not local, that the material that is found in the river, in the sediment samples, comes from outside of the catchment. So quite logically, it has to be transported by wind. So the particles, the mineral material came outside from the catchment from like 10 or 20 kilometers apart from the catchment itself. So we tried to describe this process of like catching the Aeolian particles inside of the fluvial system. With this kind of experiment, we set up a set of passive sediment samplers like in front of the fluvial system and behind it. This is the arrows shows the prevailing wind direction. So the wind goes here from the south and it crosses the braid plane of the river. So we try to catch the material which goes to the river and then catch what is after or behind the river. So we found that there's like the double amount of material is catched in front of the river before the wind goes to the river. The deposition is like 42 grams per square meter, and behind the river it's just around 30. So there's like 30% of the material which is probably catched in the braid plane of the river. And this pattern of catching or depositing the mineral material in the braid plane has quite specific like annual pattern, because the yearly pattern during the whole year, the most of the particles are deposited just on the slope where the wind speed goes down. So most of the deposition is here, but we have quite different spatial pattern during the summer when the whole landscape is dry. So the most material is deposited on the slopes of the braid plane, but the braid plane as it is, it's very wet. So there is no many like particles being uplifted and transported because the surface of the braid plane is wet and there is no place where the particles can be uplifted. You can see it on the picture. This is the end of the winter, where the slopes of the braid plane are already like snow-free, but the braid plane is very wet and full of snow. So the particles are like deposited here. And we also used the log instrument from Pavla, and we tried to catch the continuous measurement of the aerosol concentrations. On the exact side here, where is the station and where is the like, we have about 20 kilometers of bare land, which is like in front of the station. The wind goes from here, from the south, as you can see on the graphics. So from the southwest, and it goes through all this like unglaciated catchment full of like sediments. And we were able, during the 2018 season, we are able to catch 3 major like dust storms, which you can see it on the right upper picture with the wind speed, which reached like almost 20 meters per second. And there were actually like 3 events, one in January or beginning of February, which represents the end of the winter or spring summer transition, and then the late summer, which already like represents the dry conditions of the end of the summer season. So you see the big difference is exactly in the concentration of the sediment. During the first event at the beginning of the summer season, there are almost no like big concentrations or high concentrations of the aerosol in the air. On contrary, the end of the summer season, when the surface around the station on the whole peninsula is dry, the high wind speed can uplift quite large amount of the particles. It's quite interesting that all the 3 dust events were quite similar in terms of wind direction and wind speed, but the biggest difference is exactly in the concentration of the aerosol that were like observed in the log instrument. As I already mentioned, the first event at the end of January or beginning of February, there were very low concentrations of the sediment. On the other hand, at the end of the summer, the concentrations were like 2 orders higher. So we also observed that the threshold wind speed for uplifting the mineral particles like in the area is about 10 meters per second. So when the wind speed is greater than is higher than 10 meters per second, it can uplift the local mineral particles in the area. Quite interesting. We also were able to see the effect of the change in the wind direction. So the wind speed in the middle graphic is almost constant for all the day. However, at the end of the day, we observed some higher concentrations of the larger particles, and it was probably caused by the abrupt change of the wind direction, which probably activated some very local sediment sources, which are very close to the measurement site. So not just the wind speed, but also the direction from which the wind is coming to the measurement site might be quite important. And there was also one special occasion where we recorded quite high sediment concentrations or aerosol concentrations, and it was not associated with any like specific local like wind speed or wind direction effects. But what we found is that these days were quite active in Patagonia in terms of like dust storms and everything. So we checked the backward trajectories, and we found that it's exactly the day when we recorded the high concentrations in Antarctica. So it's not really proved because we don't have the physical sample, so we cannot have the chemical composition. But it seems that in certain circumstances, the dust can travel from Patagonia to the Antarctic Peninsula as well. So the next study was focused to distinguish the local and long-range sources of the material, just to see whether the findings from the aerosol counter are realistic, if we can distinguish some long-range transport sources. So we actually we wanted to estimate it also the local sources of the material from prevailing winds, and we only have like 3 or 4 like meteorological stations. So we used some physical or terrain configuration patterns that captures the prevailing winds. So we created the map of the prevailing winds, which mostly shows the south or southwestern direction of the wind on all the peninsula. And then we worked on 4 glaciers and made few, I think 7 or 8 snow pits to see the deposition of the dust on the surface of the glaciers. So I put some photos as examples, which this is from, I think, Triangular Glacier, which you can clearly see the dust layers in the fresh snow on the glacier. So we can capture in this way a few like dust events that were deposited in the snow on the glaciers. The highest sediment deposition was found on Triangular Glacier, which is this one, and also on Whiskey Glacier, which is this one. What is quite interesting for us to see the difference between the local sources and the long-range sources, we use the chemical composition or elemental composition of the dust, and specifically the calcium and silicon as proxies or indicators of the local mineral materials. So this is quite well illustrated in the graphics here down. This shows the relationship between the altitude and the relative ratio of the silicon or calcium. So it seems that as we go lower in the lower altitudes, which are closer to the local bare surfaces, we have the higher proportion of the silicate and calcites. On contrary, if we go to the upper part of the glaciers, the concentration of these minerals are getting lower. And also we investigated the specific composition of certain like heavy metals, which is the graphics here on the upper part. And for example, with the ratio of iron and titan, we can see that the sediment samples from the glaciers, which are here, are completely outside the group of the local bedrocks. So this colored like triangles and rectangles express the proportion of these heavy metal ratios in the local rocks. So we clearly see that the dust is somewhere outside. So there must be some outside source of the minerals that are deposited on the glaciers. And what's quite interesting is also that the sediment deposition rate on the glaciers corresponds quite well with the overall mass balance of the local glaciers. For example, the San Jose Glacier here was recently also identified as one of with the highest rate of thinning, with the most negative mass balance from the Little Ice Age. And it seems that the local patterns of the winds, which are here with the small arrows, it seems that the wind is like, how to say, it goes not directly over the glacier, so the deposition is very low. So there's low deposition of the sediment, but also low deposition of the snow. So this is the cause why the mass balance is so negative, why it is thinning so rapidly. So we can see that also studying the sediment deposition can somehow explain some processes that are a little bit outside of our point of view. So the next paper focused exactly on some micro scale topography and how the wind action is important in this. There are a lot of these haloclastic boulders that are spread around, that were left by the retreating glacier. And these boulders create kind of natural obstacles to the wind, and it affects the wind, the sediment deposition, the snow deposition, and consequently also the local biota. You can see some examples, and even just on the first site, you can see that there are like the depositional parts, like behind or in front of the big boulders, where the fine-grained material is deposited together with the snow. So you also see some pictures just after the snowstorm. So you can see that during one major snowstorm, there can be like 2 meters of snowpack just behind the boulders. So it also has the implications for the local biota, for the organisms, because not just the fine-grained material is deposited, but also the snow, which quite affects the humidity or the water content behind or around these like blocks. And you can see it on the picture here, right? That these parts are kind of green. These are covered by like mosses because the humidity is very high during the whole season. And this is just some schematic explanation of how it works. So you have these kind of deposition of snow, but also the sediment material, which is mostly affected by the presence of these big boulders. And finally, I put some like new data from the last season, from 2022, where we were able to capture 3 really huge dust storms. As you can see on the picture, right, this is the meteorological station, which is like 10 or 12 meters high, and it's all covered by like large dust clouds. We were quite lucky that we also had the log measurements, so we have a continuous record of the aerosol concentrations, and of course all these like wind speed, direction, and other parameters. On the picture here on the left, you can see it was taken just after the dust storm, and you can see all the meteorological equipment is covered by like about 1 millimeter thick layer of the dust. So in this case, we are able to also collect the physical sample of the dust. So it is now being analyzed in Austria, in Graz, and we still don't have the results, but some preliminary results as well. We were actually quite expecting or hoping for capturing these dust storms. So we established like a network of these passive sediment samplers, and thanks to this, we were able to capture the exact track of the sediment storm. So here on the map, you see like the spots where the sediment samplers were installed, and we actually captured these 3 major like dust storms or events. It was again at the end of February, so it's the end of the summer where the surface is dry. And because it's again, as the first article, in the beginning of the summer when the surface is wet, even the high speed doesn't trigger any like dust storms, because the mineral particles are like captured on the surface by the wetness, by the humidity, and also by the freezing, because it plays some role as well. So during these 3 dust storms, the wind speed went up to like 18 meters per second, but these are just like 30-minute averages. The actual wind speed was in the gust almost like 30 meters per second, and the wind direction was like from southwest, which goes through this like volcanic mesas, and this part is sedimentary. So there is a lot of like very fine grained material available for uplift and transport. So all the 3 storms have very similar spatial pattern. As you can see, like here is the network of the samplers, and well, of course, the bigger the dot is, the higher amount of sediment was trapped. So you can see the spatial pattern is very similar. The dust went probably through this part, and there was nothing much here. Here is actually the place with the log. So even if we are like at the edge of the storm, we were able to capture some quite high concentrations. Now Pavla is working on that, so hopefully we will have the data quite soon. The similar pattern was captured in case of the braid plane. We are also interested of how the braid plane is reacting on the dust storm. So you can see again that the central part where the actual channels are going through the braid plane is very wet. So the material was quite easily captured somewhere at the beginning of the braid plane. It didn't continue. So we captured most of the material on the edges of the braid plane on the slopes, where the slopes are very dry and easily captured the mineral particles. So what was the reason? I already mentioned, but what was the cause for these like severe dust storms? It was the prolonged dry season. Actually, 2021 was probably one of the like longest dry season during the summer, and also it was the above zero temperatures. Like for example, the first like high wind speed event was there when the temperatures were like around zero. So even if it was relatively dry, the particles was kind of frozen to the surface, so it didn't went up to the air. But when the temperatures were like here around 10 degrees of Celsius, it was quite easy with the dry conditions to uplift all the particles from the volcanic masses and also the sedimentary like platforms and remove them quite for long distances. I put like some satellite images to show that the season was really like long and dry. Like the last snowstorm or snow event was in the beginning of November. Then there was like still drying, and the first snowstorm again captured was in the middle of March. So there were almost 4 months without any like important snow event. There were just few very small and tiny showers without any significant like it didn't persist on the surface like for more than like 1 or 2 hours. Then it disappeared. So it was probably one of the longest recorded like dry summer seasons. We also have the first results from the grain size analysis from the 2 dust storms. So we see that the grain size that was it was captured on the meteorological equipment was quite big. The second sample has the mean grain size of almost 40 micrometers, but there were some part of it even above like 100 micrometers. So quite interesting and quite large particles were transported in the dust storms. What is quite interesting, the first result from the chemical composition of the dust shows that especially during the first dust storms, almost 50% of the dust was composed by the sea salt, because the wind goes also across the sea. So almost 50% of the chemical composition was sea salt, NaCl, natrium and chlor. So it's quite interesting that the wind also captures quite a lot of material from the sea and then deposited it on the surface of the land. And at the end, I put just some photos how to describe the landscape and to show some examples of how the Aeolian processes are shaping the landscape itself or interacting with the snow cover or with the fluvial systems. So the first picture, you can see that the depressions or the wet places such as lakes or river channels or the whole braid plains are quite good like catcher of the sediment mineral material. We can call it like the hotspots of the wind actions. So you see that at the end of the summer season, the whole landscape is completely like snow free. There are almost no snow at all. But you can see that still for example, the braid plain is relatively wet, so you can see the like dark places which are wet from the river coming from the hills. This is a picture of the Algal stream, which is now fully loaded with the sediments, and the photo is like 1 or 2 days after the snowstorm, the dust storm. So you can see that the rivers are really like transporting like a great amount of the sediments, which usually comes from these like dust events. Another example is probably one of the biggest rivers, the Seal Stream, and again the quite large like braid plain, and on the edges you can see like the deposition of the Aeolian material. What's quite interesting also is if you see like this person is going, and the surface is very like soft and composed of very like fine grained mineral materials. So you can see that the tracks are really like deep. So you have like 5 to 10 centimeters of really like soft material unsorted and probably deposited by the wind as well. Here you can see like the interaction of the fluvial processes and the wind deposition. Like all the material which is here is deposited by the wind and then transferred by the melting snow and the fluvial processes which are taking or are flowing the Aeolian material down to the rivers. Here's just a close-up view of how it looks like inside of the braid plane. So you see that all the like edges of the braid plane are made of this very fine-grained mineral material, which is deposited by the wind, and then transferred by the fluvial processes during some flood events. You can see that the layer of the accumulation of the Aeolian accumulation could be quite high. And here's the example of like degrading permafrost and about like 20 or 30 centimeters of like sediment above it. Here you have a like quite nice example of how the snow cover quite nicely captures the dust that is transported. So you see like different shades of the gray on the landscape and on the snow patches. So you have the combination of the new snow cover here and some older layers with the sediment layers of the Aeolian dust. What is quite interesting as well is the like small river valleys that are incised into the landscape, and these creates quite a nice like natural sediment traps or also snow traps. During the dust storms, they are usually like filled with a few meters of snow, but also then as the surface is quite wet during the above zero temperatures, it captures quite well the sediments. So again, you can have like very like thick sediment layers captured on the surface of these like snow patches in the river valleys. So then when the snow melted away, then you have these like plots of sediments that rests on the surface of the braid plane, and that can be later transformed or transported by the river action. So you can see even some like nice Aeolian shapes again in the depressions. Some like microforms as well, and you can again see like the very like thick layers of the Aeolian deposits. So some few words at the end. So we think that the Aeolian processes play quite an important role in the local sediment budget. And we also expect that the role will be still more and more important as the landscape or the whole Antarctic Peninsula region will become like more warm and probably even drier, at least at our like eastern side of the Antarctic Peninsula. And there's also quite interesting interaction between the fluvial systems and the Aeolian transport, because the Aeolian transport is probably quite the leading process that is transporting the material to the rivers, and that is later transported to the sea by the river. So the controlling factors for uplift or transport of the Aeolian material is the wind speed, the above zero temperatures, and also the surface wetness, or in this case dryness of the surface. And the controlling factors for the deposition, for where the sediments are deposited, is the terrain configuration, both in the micro scale, like in the example of these like boulders, but also on the micro scale. It's also deposited in the river valleys, in the like natural depressions. And we can expect that with the ongoing changes in the climatic system, these Aeolian processes can be still more and more intense. We can expect the prolonged dry season, prolonged above zero temperature periods, and also the lower water content in the permafrost active layer. And there's also another question of the long-range transport, for example, from Patagonia, which is quite an interesting question, which we will probably address in our new sediment samples and our chemical analysis. So that's basically all, and thanks for attention.
So thank you, Jan, for the very, very interesting talk and with very nice photos also describing the circumstances. So we are a little bit behind the schedule. I didn't want to interrupt because the talk was so interesting. So it is all up to me. Yeah. So we have time for one quick question at least. Do we have anything in the chat? Let's check first. And if anybody has in the audience a question, please feel free to put your camera on and present your question as well.
So nothing in chat.
Nothing.
But so I would have one if nobody. So yeah,
I'm not sure if we are still on the.
Are we offline?
I don't know. I can't get there.
I think our chat is closed. Hopefully not. No, I can see it. I
Okay, so
open here and there is no. But yeah, so I'm actually a little bit confused. What are the sources of the dust then? Because it seems the riverbed is too wet. So
the sources.
which
I mean, it's a mixture of like local sources, probably for the biggest particles. But there is also the sources from outside of the Ulu Peninsula for the finest grain mineral particles, probably.
And inside the Ulu Peninsula, would it be the slopes or the top of the mountains, or?
Well, that's the question, because
so hard to say
I think it's like combination of everything, because the material is like transported and sedimented again, so it's like resedimentation.
Yeah.
Because the biggest particles are probably just like saltating. So they can be probably transported like 100 meters during the one storm and then continue. So, but actually, like south from the Ulu Peninsula, there is just the ice cap. So there are no other like big ice-free areas. There are some, but so
okay, thank you.
there is some part of the material which goes probably from the Antarctic Peninsula. There are some ice-free areas, but I think we have to wait for the detailed chemical analysis that is now going on.
Okay, so thank you very much. And we will have now a short break, but the time was reserved in the break if we are a little bit late longer. So we will meet again at 2:20. I will just make sure they are back in Zoom here. Are we still on the Zoom meeting? Yeah, stop share. Here we are. Yeah, so I would like to thank all the speakers of the first session for great contributions, and we will meet again after almost little bit more than 10 minutes. We will continue with the talks. Thank you.